In this video, we want to evaluate these two integrals using a trigonometric substitution. Now, in an earlier video, we worked out the same two problems using this integration formula for arctangent. Any integral in the form du over a squared plus u squared has a value of 1 over a arctangent of u over a plus the constant of integration. So I mentioned then that if you don't have access to this formula, or if your instructor doesn't let you use it, because maybe you haven't gotten that far in the course and he wants you to use a trig substitution, which is what it was used to derive this formula. If you want to derive this formula, you can use a trigonometric substitution. So these are the answers we got in that video. Pretty straightforward, just a step or so. The first one was just one step. In the second one, we had to use a U substitution to get it in the appropriate form to use the formula. And then we got the answer that I have here. So these were the two answers that you should get if you use the trig substitution that I'm going to go through right now. You can pause the video here to check these out. So I could do a U substitution for this one also, but again, I mentioned it then that if you let U equal to x minus 3, then du would be dx. So I'm going to do the same thing here. For the U substitution, I'm just going to say that x minus 3 equal to 3. X minus 3 will equal to 3 tangent of theta. And then taking the derivative here, on the left side we get dx. On the right side we get 3. Derivative of tangent is secant squared theta, d theta. So in my substitution here, going to the variable theta now, this gives me the integral of 1 dx, or dx is going to be 3 secant squared theta, d theta. In the denominator, I'm going to have the 9 plus, and then the x minus 3 right here, squared, and that would be the same thing as 3 tangent theta squared. So this would give me a 9. Looking at the denominator, I got 9 plus, and then x minus 3 squared is the same thing as 9 tangent squared theta. Factor out the 9 here, that gives me 1 plus tangent squared theta. But 1 plus tangent squared theta, that's the same thing as, from your trig identity, that's the same thing as secant squared. So I get secant squared theta. So that'll go in the denominator. I get 9 secant squared theta. These cancel out, this cancel out, and this gives me with 1/3 here. So all I have then really in the integrand is 1/3 d theta. So it's the integral of 1/3 d theta. And I can just write it in, 1/3 theta. So 1/3 d theta, integral of that is 1/3 of theta, plus the constant of integration. Then from this equation right here, this substitution here, that would tell me that tangent of theta dividing by 3 is x minus 3 over 3. Take the tangent inverse at both sides. On the left side I get theta, and on the right side I get tangent inverse. I'm going to write that as arctangent. Same thing, arctangent of x minus 3 over 3. And I just put the answer there in here. Then this would be 1/3 arctan. This is x minus 3 over 3 plus the constant of integration. And that's the same answer that we got using the integration formula for arctangent that I just showed you. So 1/3 arctangent of x minus 3 over 3 plus the constant of integration. A little bit longer than from the other video. That's because in the other one we used the formula, so we could go directly to the solution. Let's clear this one here now. On the second one, we have to do a little bit more work. We don't have it exactly in the form that we wanted to use a U substitution, or a trig substitution, I should say. So what we'll do is this, and I did this much on the other one. We started this way, x to the 4th is the same thing as x squared. So we came over here and said, okay, now first we use a U substitution to get it in the appropriate form, and said, yes, let's let u equal to x squared. Then du is equal to 2x. Derivative of x squared is 2x, and then it's dx here. Divide both sides by 2, and we get x dx is equal to du over 2. So now let's transform this integral first now into one involving the variable u. So for the x dx here, put that together. We're going to replace that by du over 2. I'll put the 1/2 out in front, and my du would go here. And then x squared is u. This will be u squared plus 16, or 4 squared. Now from here, we have it now in terms of u. Now we can go to trig substitution using the function tangent. And let's say that u equal to 4. And of course the 4, because of this 4 squared being 16, and the variable being u in this case, 4 is 4 tangent of theta. So then du, now we're making the transformation from the variable u to the variable theta. This will be 4, then derivative tangent then is secant squared theta. And then this will be d theta. Then we're going to divide through by 4 here to isolate. Well, actually, no, we're going to leave it like this because we want to replace the u here. This would be a 1/4 here, or 1/2, I should say. The integral, and du is going to be 4 secant squared d theta. And again, from the denominator here, we got u squared plus 4 squared. So I want to find a replacement for that. So since the u is tangent theta, let's square that out, and we're going to get 16 tangent squared theta plus 4 squared, that's your 16. If I factor out a 16 here, I'm going to get 16, and that's going to leave me with tangent squared theta plus 1. Okay, take out the 16, leaves me with tangent squared theta plus 1, but that's secant squared. So the denominator can be replaced by secant squared theta. I'll come back over here then and put a 16 here, and this will be secant squared theta. So we got 4 over 16. 4 over 16, that's comes out to 1/4, and then I got a 1/2 out in front. So this is going to be 1/8 out in front. And I'm left with the integral of the secant squared, and the secant squared also cancel out. So all I have is d theta, or 1 d theta. Integral, this same thing as 1 d theta, same thing as 1 d theta. So we integrate there, and that's going to be 1/8 of theta plus the constant of integration. But remember, from right here, divide by 4, and this tells me that tangent of theta is equal to u over 4. If I take tangent inverse on both sides, or arctangent on both sides, on the left side, that's just going to leave me theta. Taking arctangent on both sides, from this equation here, I'll get theta is equal to arctangent of u over 4. But u is x squared, okay, in this one. We started off with the u being x squared. We get arctangent of x squared over 4. That was the initial substitution. So to finish it off, let me just go over here. Going to wind up this right here. This will be 1/8. Theta again is arctan of u over 4. And our substitution was u was x squared. To start off with, this was x squared over 4. And then it's plus the constant of integration. So this is the answer for this problem using the trig substitution. U equal 4 tangent of theta. And it's the same answer, just like it was in the first one. We got the same result as the ones we did in the previous video. And I'll go ahead and put a link to that video in case you want to refer to that. But this is the way you would get the same answers we got last time using a trigonometric substitution. Thanks for watching. We'll see you next time.